All right, moving on to 2.6. We're going to divide 2.6 notes up into 2 days. So today we've got part 1. 2.6 is about solving proportions. Solving proportions. A proportion is an equation stating that two ratios are equivalent. A proportion is an equation stating that two ratios are equivalent. So, it's just two ratios, and they're put together with an equal sign, saying that the two ratios are equivalent to each other. So we're going to solve these proportions today and tomorrow. Any questions before I move on to some examples? Hey, I got 2 examples and I'm done with notes for today. Okay. Solve the proportion. If necessary, round to the nearest hundredth. Solve the proportion. If necessary, round to the nearest hundredth. So a ratio is just comparing two things. You might see them with a colon between them, but most of the time in math, we'll see them kind of written as a fraction. Okay? So here I've got x over 45 equals 15 over 25. And there's a couple ways we can go about solving these proportions. One method to solve our proportions is to multiply by things to cancel out our denominators and give us a little bit easier equation to deal with. So in this case, on the left-hand side, I've got x being divided by 45. What's the inverse of division?
Multiplication.
Multiplication. So I can multiply by 45 and cancel it out on that left side. Whatever I do to one side of an equation, got to do the exact same thing to the other side. So on the left, the 45s cancel out. What am I left over with? X. And on the right, I've got 15 over 25 times 45. If someone's got a calculator, can you type that in your calculator for me? Nope. Put that away. If you have one of my calculators, go ahead and type it in for me. 15 over 25 times 45.
675. Did that in my head that way.
675. X is now by itself. There's my value of x. Everyone okay with that? It's not hard, is it? So there's one way of approaching solving a proportion. Another way that I can solve a proportion like I said, proportions will more than likely be represented as fractions to us in math. Another way we can solve a proportion is using what you guys like to call the butterfly method. Okay? I can multiply diagonally these two things and these two things. And then set those two things equal to each other. So, what's 25 times x? 25x, so that's one side of my equal sign. Equals, what's 45 times 15?
675.
No. What is 45 times 15?
675.
45 times 15?
Yeah.
Well then, we got this wrong right here.
I think 45.
We're supposed to do, over here, on the first example that we did, we're supposed to do 15 over 25 times 45. So what do we get for that?
27.
That equals 27, okay. There we go. So, 45 times 15 gave me what? 675?
Calculator malfunction.
And then on this equation, after I multiply diagonally and set each thing equal to each other, how would I get x by itself?
Divided by 25.
Divide by 25.
27.
675 divided by 25 would give me 27. So, if I have a proportion, I can multiply diagonally, set each thing equal to each other, and then solve for x. Or, on this one, it was really easy just to multiply by 45. X is already by itself. So there's two ways to approach solving a proportion. Any questions about that? Questions on example 1? Can I move on to example 2?
Yes.
Solve x over 9 equals 2x minus 3 over 24. If necessary, round to the nearest tenth. X over 9 equals the quantity of 2x minus 3 divided by 24. I'll show you both ways once again. Which way would you guys like to do first? Would you like to try to cancel out some denominators or go ahead and do butterfly method? Cancel out some denominators. So what would you guys do to cancel out some denominators here? Huh? Yep, I can multiply by 9. That'll cancel out my denominator over here. I've got to multiply this side by 9 as well. On the left, I've got x, because the 9's canceled out. Now, on the right, be very careful here if you're doing this. 9 as a fraction is 9 over 1. And for fractions, I multiply straight across. Numerator times numerator, denominator times denominator. Okay? What's in my numerator here?
Exponent. Yeah.
Well, read off. What's in my numerator here?
2x, subtract.
2x minus 3. The whole thing. 2x minus 3 is in the numerator. Correct? So, this whole numerator, I have to multiply by 9. So I've got to use what?
Distributive property.
Distributive property. So 9 times 2x,
18x.
18x. 9 times negative 3,
Negative 27.
negative 27. And then in my denominator, 24 times 1,
24.
24. Everyone okay with what I've done so far?
Yeah.
So I got rid of one of my denominators, right? How would I get rid of the other denominator?
Times 24.
Yeah. This whole side, 18x minus 27, is being divided by 24. Inverse of division is multiplication. So if I multiply by 24 to cancel out, whatever I do to one side, got to do to the other as well. What's 24 times x? 24x equals, what do I have on the right side?
18x subtract
18x minus 27. Because my denominators canceled out. Is everyone okay with how I canceled out both denominators? Just multiply by the denominator on both sides. It'll cancel one of them out. Do your calculations. Then multiply by the other denominator on both sides. It'll cancel out. Do your calculations. Now, I've got to solve this for x.
Add
Not add 18x.
subtract 18.
Subtract 18x. Why did you say add 18x first? Because of this minus sign right here? Okay. Whenever I am moving things using inverse operations, I want to use the sign that's immediately in front of the number I'm trying to move. Yeah, this is a positive 18, so to cancel it out, I need to subtract 18x. I want to get the variables to both sides, right? Or to the same side, I mean. 24x minus 18x gives me
6x.
6x. What do I have left over on the right? Negative 27. Now, how would I get x by itself?
Divide by 6.
Divide by 6. Negative 27 divided by 6 gives me what? Negative 27 divided by 6 gives me what?
Negative 4.5.
Negative 4.5. Did you already round, or is that just what it gives you?
That's just what.
Okay, negative 4.5. Is that rounded to the nearest tenth for me?
Sure. Yeah.
Where is the tenths place?
The 0.5.
Yeah, the tenth place is the place right after the decimal to the right. So, it's already to the tenth place, so I don't have to do any rounding. Here's my answer. Any questions on that version of example 2?
No.
Okay, let's look at the butterfly method now. Okay? Butterfly method, I'm multiplying things diagonally.
I don't like this.
What's 24 times x? 24x equals, I'm doing 9 times 2x minus 3. So once again, I've got to use what? Distributive property. I've got to multiply every term up here by this 9. 9 times 2x.
18x.
18x. 9 times negative 3.
Negative 27.
Negative 27. And then from there, it's the same work we just did
True.
from here on. Does that make sense?
Yes, sir.
Everyone okay with that? So, solving proportions, there's a couple ways you can approach it. You can either cancel out both denominators like we did here first, or you can use butterfly method where you multiply diagonally, put each product on each side of the equal sign, set them equal to each other, solve for x. Okay, if you like it better, go with it. That's only for proportions. If you got a fraction equals a fraction. Okay? If I got any other type of equation, I can't use the butterfly method. If I'm multiplying fractions, I can't use the butterfly method. I got to go straight across. If I'm dividing fractions, I don't use the butterfly method. I got to do something else. I can only do butterfly method if I've got a fraction equals another fraction. Everyone got it?
Yes, sir.
Questions about the notes for today? You're looking for 2.6, homework number 2, MH on Canvas.
Is it long?
I think there's like 18 problems. Not too bad, but you got a lot of class time to do it. Any questions about the notes before I end the recording?